Hello everyone, I'm going to introduce you today to Ohm's law, which is the relationship between the voltage, current, and resistance. Before we go actually to the law itself, let me introduce you for this tool from Colorado University. And this is a kind of animation and simulators, how to construct simple electrical circuit and how to implement this circuit to understand the Ohm's law. Just very quick, actually, for the simple circuit or the simple electrical circuit, we need a battery for voltage as a source for voltage, and also need a bulb, and then we need a switch, for example, and of course we have to connect all of this by wires, right? So this is just to give you an idea about what we need to do and how to connect different part of the circuit. So for example here, yeah, just very quick here, connection, how to connect this kind of parts, okay? Before actually I came here, so I did two circuits, basically, yeah, to go again, just to delete this ones, and the ones that I did here is just yeah, this is just to show you how to use or how to eliminate this kind of element. So let's actually assume that we have two circuits here. The first circuit is a bulb of a voltage source, which is a battery here, and a switch. And then similar to this one. So what happened here? If we connect the switch, what happened? Oh, wow, there is some electricity comes, okay? If we put this off and we put this one here, oh, you see, oh, interesting, what happened? So what happened here? If you look at these two circuits, what you can see, the first circuit is having a 9-volt battery, and the resistance is 10 ohms. And this very slow movement of electrons from the negative end of the battery to the positive end. Here, this is the positive end, and this is closer to the bulb, and this is the negative end where the electrons flow through the switch to the other end of the bulb. Okay, can win this one also here maybe. What happened here again? So if you look at this one here, you can find actually that with low voltage, the light actually is not really high or dim. And if we have higher voltage, what happened? Oh, wow, very, very shiny bulb here. The electron actually move very quick. This means that you have a lot of actually electricity comes out. Okay, how to understand this one from Ohm's law? And here is the Ohm's law. Ohm's law stands for the relationship between the voltage and current, which is I. So basically voltage V and I is the current. And of course we have a resistance. In fact, the Ohm's law stand or the relationship between the voltage and amp or the current, and this is basically what the stand for is that voltage is proportional to I. So in the first form of this one, V proportional to I, and when we take this proportional sign out, we have to use some kind of constant, which is R in this case. So basically we came up with voltage equal to IR, and the resistance, of course, this is the resistance of the elements that we have in the circuit. And it depends on, of course, the type of wire, the characteristic of wire, such as how long, what is the thickness of basically the cross-section area, what is the metal type, that is wire made of. All of this actually factor affecting the value of R. Okay, so again, if we have a simple also a simple circuit, we have a voltage source, which is a battery here. It's just 1.5 volt, and we have resistant here. And here, this is the resistance is, if you look at the right hand side here, you can find the voltage is 1.5 and the resistant is 166 ohms. And in this case, we can find the relationship. Now we need actually the I. How to get I? I is, of course, is the voltage divided by R. So if you divide the voltage 1.5 divided by R, in this case ohms, you will get actually how many amps. So basically 1.5 divided by 166, this give you 0.009 amps, which is 9 milliamps. So basically here, this is a current here is 9 milliamps, which means that, of course, because the units here, the voltage is in volt and the resistance in amps. So in this case, the current should be in ampere. Ampere there is the unit for measuring for measuring the current. But because actually we have a small voltage compared with the resistance, so basically we have to use the milliamps in this case. Okay, what happened here if I increase the voltage? So basically, if I increase the voltage before actually we see any simulation, if I increase the voltage, what you can expect actually, if we have the same the value R constant, you would expect actually the I to increase, right? So basically, this is proportional relationship or positive correlation. Increasing the voltage at similar R increases the I. Okay, let's see. Increase the voltage, increase the voltage, increasing the I, right? Increasing voltage, increasing I, increasing I, increasing I. Okay, reducing the voltage, reducing the I. Okay, what happened here if I kept the voltage at say total voltage in this case is 4.5 volts. We have 3 batteries here, it's 4.5 volts, and in this case, and we have the resistance, for example, here we have 100 or maybe 105 amps ohms. Sorry, resistance is 105 ohms. In this case, we can expect that the current should be 42.9 milliamps. Again, we have to have milli here because basically we have very big resistance, and in this case we can divide we can multiply the amps by 1000. We can get how many milliamps. Okay, again, what we did here, we kept the voltage at 4.5 and the resistance in 105. Okay, so if I wanted to increase the resistance, if I increase the resistance, what happened? The amps will be reduced. Wow, you see, until here. So basically, if I have 975 ohms as a resistant, we can expect the current that can be flown through this circuit with 4.5 voltage. It will be 4.6 milliamps, and you can actually play around with this very much, actually keeping the R constant, or you can keep the voltage constant and increasing the R. You can get actually the I, how much you can get. Okay, so this is basically the Ohm's law.